This video is all about using the concept of the mole to actually start to do some more calculations. And in particular, we're going to talk about a new concept called the molar mass. So below you see a bunch of pictures here. We know from the last video that a mole is equal to 6.02 times 10 to the 23 of anything. So each petri dish in these pictures here contains exactly 1 mole of the element or compound. What I want to point out to you are the differences. So here's a mole of copper, there's a mole of carbon, here's iodine in there, there's sulfur, and then on my second picture, I guess you could call it, I've got copper 2 chloride, copper 2 sulfate pentahydrate. I've got, I think it's zinc chloride there, I can't really tell. There's water, H2O, and each one of those petri dishes, each one of those samples has exactly 1 mole, or 6.02 times 10 to the 23 atoms or molecules in it. So how do we actually measure the mass of 1 mole of an element? Well, we use this new concept called the molar mass. So that's here. So the molar mass, its definition, is the mass of a mole of atoms of an element. Here's the awesome part, is that it's numerically the same as the atomic mass from the periodic table. So that means we can actually get it straight off the periodic table. PT for periodic table, which makes it really easy for you guys to be able to find the molar mass. The reason why this is true is atomic masses are a comparison of each atom to the standard carbon-12 atom. So that's kind of what makes this whole thing work. A couple other new terms. Molecular mass is the sum of the atomic masses of all the atoms in a covalent compound. Okay, and again, it's numerically equal to the molecular mass in AMU. And then the last one is, formula mass, and that's the mass of atoms in an ionic compound. Again, the same as the formula mass straight off the periodic table. So you'll notice that here our units for molar mass are in grams per mole, which means the mass in 1 mole. Okay, so grams per mole, mass per 1 mole of a substance. And you'll also notice that we have 2 different terms there. The molecular mass has to do with molecules. The formula mass has to do with ionic compounds. So you might see those sort of interchangeably, or not interchangeably, but you might see those 2 terms in your textbook or on a handout as we go through the rest of the unit. So here's an example of 2 elements, magnesium and neon. And you can see I know the mass of 1 atom off the periodic table. If I look on the periodic table, 1 atom of magnesium is about 24.32 AMUs, or we use the Greek letter mu. That means that 1 mole of atoms is 24.32 grams. So all I did was I changed this unit from AMUs into grams, and now suddenly, yay, I have exactly how much a mole is. So that means if I weigh out 24.32 grams of magnesium, I should have exactly 6.02 times 10 to the 23 atoms of magnesium in that sample. Then the same thing for neon. Again, it's 20.2 AMUs, so my molar mass becomes 20.2 grams. All I do is take away that unit and I put grams. Done. Molar mass. Example 1, here's an example where it gets a little bit more complicated. What is the molar mass of water? So now we have water. It's a compound, H2O. So to do this, I have to add up all the elements in that compound. So here, I know that 1 molecule of water is made up of 2 hydrogens and 1 oxygen. So I have to actually add those up. So that means I have to take 2 times 1.01 grams per mole, not straight off the periodic table. That's my molar mass of hydrogen. And then I use my molar mass for oxygen, which is 16.00 grams per mole. And again, that's straight off the periodic table. I punch those numbers into my calculator and add them up, and I get 18.02 grams per mole, which means if I weigh out 18.02 grams of water, I will have exactly 1 mole of water. Easy peasy? Great. Try these. Find the molar mass of each of the compounds shown below. What I'm going to do is I'm going to write down all of the answers for this. Maybe I can do one more quick example for you. But what I'd like you guys to do is pause the video, try these out on your own, and see if you're getting the same answers as me. If you're not, see where you went wrong, or come and see me during class or after class. So the molecular mass, or the molar mass, sorry, of phosphoric acid, H3PO4, if you add all those up, you should get 98 grams per mole. Or it should be 98.00, however many decimal places you have, good. Copper 2 sulfate pentahydrate. I'll do this one for you just because it is a hydrate and people get confused with it. This whole molecule is made up of 1 copper, 1 sulfur. I've got 9 oxygens total. I've got 4 here and then another 5 there. So you can group them together or you can split them up. I like to group them together because it's faster. And then I have 10 hydrogens. So just because it's a hydrate doesn't mean you need to panic. You just need to add up everything in that molecular formula. So if I do that, I have my copper is 63.55 grams per mole. I've got 1 sulfur, that's 32.07, I think. Let me check that. Yep, that's good. I've got 9 times 16 grams per mole of oxygen, and I've got 10 times 1.01 grams per mole my hydrogen. So if I add all those up together, my final answer for that one is 249.72 grams per mole. So that's my molar mass of copper 2 sulfate pentahydrate. Okay, so hopefully you get that and that makes sense to you. That's sort of as complicated as it's going to get. The answer for number 3 should be 186.75. Notice how I'm always putting in my units. You're going to get marks off if you don't put your units on. Ammonium phosphate is 149.12 grams per mole. And this potassium aluminum sulfate dodecahydrate. Yikes! It's a big molecule. You should still be able to add them up. 474.46 grams per mole. So again, take some time and make sure you're getting the right answers. Remember what I said. You have to punch these numbers into your calculator and make sure that you're getting the same answers as me. If you're not doing that, I guarantee you are not going to be as successful in this unit as you would like to be. Don't be lazy. Punch these in, get the same answers as me, and if you're not, come and see me right away for extra help. Okay, so the factor label method, this is the method that we're going to use to solve most of our mole problems, and we've already sort of looked at it when we were looking at unit conversions. So I'm going to talk you through the steps with an easy example, and then we'll do 2, maybe 3 examples of mole calculations. So we're going to use these to solve mole problems. Here is an easy example. The running time of a movie is 90 minutes. How long is this in hours? Most of us can do this in our head. It's an hour and a half, 1.5 hours. But I'm going to talk you through the steps for simple problems so that you can apply that same knowledge to a more complex problem. So, a conversion factor is an expression for the relationship between units. So basically what it means is it's the same thing, just expressed with different units. So 1 hour is the same thing as 60 minutes. We just have different units. So step 1, you have to write down what you are trying to find on the left, then put an equal sign, and then put what you are given on the right. So if I do that for this problem, I get number of hours, that's what I'm trying to find, put an equal sign, and then I'm given the quantity that's given to me in the problem, 90 minutes. Step 2, and this is usually the hardest part, you've got to find a conversion factor that will work for you to get the answer that you need. Here's the trick. You have to put the unit that you want to keep on the top and the unit that you want to cancel on the bottom. So in this case, I'm going to put the hour on top and the 60 minutes on the bottom so that when I go to cancel out the units, they cancel out properly. So here you can have a look. Oops, why didn't that work? There we go. There we go. So here my minutes cancel out and I end up with hours, which is the units that I want to keep. Yay! So what do I punch into my calculator? I take 90 times 1 divided by 60, or just 90 divided by 60, and I get 1.5 hours. Done. So that's pretty straightforward. How do we apply that when we convert using moles? So converting with moles is really important. It's pretty much what you're going to be doing for the rest of the course, so make sure you pay attention and rewatch this video as often as you need. If I say want to go from number of atoms or molecules to the number of moles, the conversion factor I'm going to use is going to be Avogadro's number, which is 6.022 times 10 to the 23. So that means, again, you have to write in a conversion factor the 2 things that are equal. So in this case, I know if I have 1 mole, I have exactly 6.02 times 10 to the 23 atoms or molecules. Okay? Or the other way I can write it that equally makes sense, if I have 6.02 times 10 to the 23 atoms or molecules, I also know that I have 1 mole. Okay, so because those two quantities are equal, I just have different units, I'm allowed to pick one or the other. So I can actually flip them, just like I showed you here. So I have to pick the one that's going to cancel out the units that I want to get rid of and keep the units that I want to keep. So that's our conversion factor, going from number of atoms or molecules to moles, or vice versa, back the other way. Now, to get something to do with mass. Okay, so if I want to go from moles to mass or mass to moles, my conversion factor that I use is the molar mass, which you just learned today in this video. So again, you could have the mass, whatever it is from your periodic table, divided by, divided by 1 mole. Or you could have 1 mole equals to the molar mass. Either way, they both will work for different scenarios depending on what you need. So again, if you need to cancel out mass, you're going to use this one. If you need to cancel out moles, you're going to use the first one. So let's do some examples so that you guys can see how this works. This picture here is actually going to appear on the rest of the slides. So here's example number 1. How many moles are in 32 grams of potassium? So I have 32 grams, I have a mass of potassium, and the question is asking me to find the number of moles. Okay, so the conversion factor here is going to be your molar mass. Let's follow the steps that I've been giving you in the videos and in the problems to see if we can solve this really, really easily, okay? Because I know this concept of a mole is different and new for you, and it might be tough for you to figure this out on your own. So follow the formula. You write down, what are you asked to find? I'm asked to find how many moles. So I'm asked to find the number of moles of potassium. Then you write an equal sign. Then you write the number that's given to you in the question, which in this case is 32.0 grams of potassium. And then you're going to multiply that by some sort of conversion factor. So this is a tricky part, figuring out what conversion factor it is. So let's see. I know I'm going to use the molar mass. My molar mass for potassium is 39.1 grams. And I know if I have 39.1 grams of potassium, I have exactly 1 mole of potassium. Or I know that if I have 1 mole of potassium, so that should say 1, I have 39.1 grams. So those are my two options for conversion factors that I can plug in here. So in this case, I want to use this one. And here's why. I want to make sure grams is on the bottom so that it'll cancel out, and moles is on the top of my fraction because that's the unit I want to keep. So that's what I'm going to put in. So I will actually write 1 mole over 39.1 grams, okay? And if I actually do that, I plug that into my calculator, I should get, oh shoot, I just cleared it. .81841432, and what happened? My grams canceled out, and I'm left with moles. So I have that many moles of potassium. Okay. Now I'm not quite done. You have to remember to round to your significant figures. So in this case, I have 3. So 0.818 moles of potassium. So that right there, that's my final answer. And that's what I expect to see on your quizzes and tests and assignments. I want you to show me all your work just like this. So that's how you do it. And that's how you pick a conversion factor properly. So you have to remember, write down what's being asked for you to find, what's given to you in the problem, then times it by a conversion factor. If you follow that formula, you honestly can't go wrong in this course. So let's do one more example and see how you guys do. The rest of them we'll do in class. I'll actually post up the answers in class and we can do them then. So here's another example. How many molecules are in 40 grams of water? So again, I gave you mass, I give you 40 grams of water, and I want you to find, in this case, the number of molecules. Yikes! You'll notice if you look at that little picture in the corner there, there's no direct way, there's no one step to get from mass to molecules. There's no conversion factor to do that. So the first thing I have to do is convert everything to moles, and then I can go back and convert to atoms and molecules. So I've got to first go from mass to moles, and then I got to take my moles and change that into number of molecules. So let's do that the same way. Let's do step 1. Actually, you know what? I'll color code this for you. So I'll do step 1 in green, and then I'll do step 2 in blue. So step 1, I'm asking you to find the number of moles of water, H2O. Then you write an equal sign. Then you write what's given to you in the problem. In this case, 40 grams of water. Now we're going to times it by a conversion factor. So again, my conversion factor is going to basically cancel out grams and keep moles. Okay, so I need to put grams on the bottom and moles on the top. And I know it's going to be my molar mass, okay, because molar mass is moles and grams together, so I punch in my numbers so I know I have 1 mole, and we calculated earlier on in this video that it's 18.02 grams for every mole of water that you have. So when I do that on my calculator, I get 2.219755827 moles, because again, if you look, my grams canceled out, and I had moles left on top, so that's my unit that I write down there. So I'm halfway there. Notice I'm not rounding to significant figures, okay? You only do that at the very end of the problem. So I'm leaving all these numbers here. I don't want to round. Otherwise, what ends up happening is my answer becomes less precise because I've rounded twice instead of just one time. All right, so now that I know how many moles are in 40 grams of water, I need to find how many molecules of H2O I have in my sample. Okay, so in order to do that, I just wrote down here number of molecules of H2O. That's what I'm being required to find. I write an equal sign, and then I write what's given to me. So 2.219755827 moles. And again, I'm going to pick a conversion factor. Now this conversion factor is Avogadro's number. That's what's going to get me from moles to number of molecules. So again, what do I put? I have to put moles on the bottom because that's the unit I want to cancel out. And I'm going to put molecules on the top because that's the unit that I want to keep. Now what do I fill in? I know Avogadro's number tells me I've got 6.02 times 10 to the 23 molecules in 1 mole. So that's how I know which number to put on the top and which number to put on the bottom. So I basically take my answer and I times it by 6.02 times 10 to the 23, and I get 1.331853496 times 10 to the 24 molecules of H2O. Okay, now I can round. Now it is okay for me to round to my final answer, which in this case should have 3 significant figures. So 1.33 times 10 to the 24 molecules of H2O. Done. Okay, so that's the answer for number 2. What I'd like you guys to do is maybe try and do number maybe 3 and 4 on your own and see if you can. I'll flip to the next slide, and what I can do is just post the answers for the next few questions up. And so if you want to try them on your own, you can check to make sure you're getting the right answer. So here's example number 3. So your final answer for this one should end up being 4.52 times 10 to the 24 molecules of H2SO4. If you want to do example number 4, here's the answer. It should be 1.9 times 10 to the 24 molecules. That's a 2 molecules. Number 5 in your notes is 2.32 moles. Number 6 should be 48.1 grams. Number 7 is 1.2 times 10 to the 23 atoms, I believe. That's a tricky one. And number 8 is another sort of tricky one. It should be 3.69 grams. So, however many you want to try is great. Like I said, we will do the questions together as a class and to make sure that everybody's getting the right answer. So if you have any questions, don't forget to ask me in class.